It's my pleasure to announce Luca Melete and Florian Bräunlein now. And we'll be hearing about measuring vulnerability levels across organizations, industry, and countries. Looking forward to your deep scans now. Please give them a warm welcome.
Thank you. It's with pleasure that we are here in Vienna. Fabian was here last year. This is the first time for me. This time, at least for who knows me, I usually talk about mobile networks and Fabi, IP cameras and payment terminals, whatever. We got to a new topic, and we are happy to share our insights with you. This time, we scan the internet. You would think that this is something already done, but we think that it was never done in a way that it helps the community to fix the bugs, fix the issues that are on the internet. And I want to describe where we started from. So our motivation was a question that we often hear as researchers, and that comes from security officers in companies. So the defense point of view. The guys that are trying to secure their companies often have a large list of things to do, right, to fix their vulnerabilities, and they don't know where to start. They don't know which one is the one that they need to fix. And another recurrent question is, am I so bad? How are the other guys doing? Is this what I see in my report, is it something that everyone has, or I don't know, I'm the only one? And when this happens, I guess the security officers are seeking for answers in the research community, so security researchers here. On that side, we know very well that security researchers often focus on a very specific topic, and they go global. So, for example, Heartbleed or any big bug, and they scan the internet and they say, well, I found 1,000 IPs vulnerable to this vulnerability, but actually I don't know how to answer your question. How do you compare to the others? And we wanted to kind of solve this problem. We wanted to give an answer to these guys. And for doing that, we need to analyze what is the difference between the defense and the attacking side. It's the methodology. So on the defense, you often have all these security tools, commercial tools, open source tools, and what I imagine this security officer doing is using all these tools on the whole IT infrastructure of his company, and he's getting a bunch of different vulnerabilities. He gets the usual reports. And well, there are many types, and but the point is that those are only relevant for the company. So he does not know what happens outside of the company. And then we have the other methodology, so global scanning. Global scanning, typically, you pick a port, you find your POC to verify that the vulnerability is there, and you launch your mass scan, you scan the internet, and then you have an IP count, let's say 2,000. You have found 2,000 hosts that are vulnerable to your vulnerability. Okay, this was global, but very specific to a vulnerability. On the other side, it was covering the whole infrastructure with everything, but not able to tell anything about the rest of the world. And we wanted to join these two methodologies together, and that's what we did. We scanned the internet with basically a large amount of different vulnerability checkers, and we got some results. And you will be surprised, for example, to know that banks in Europe are less secure than banks in North America or banks in Asia. Well, that's only one of the findings that Fabian will illustrate later. But to understand better how we measure security, I have to introduce what we call the hackability score. We needed a way to, yes, find the numbers, find vulnerabilities on the internet, but also have a comparison metric. The numbers are big. So when you scan the internet, first of all, there's a fact. If you consider the IPv4 space, that's 4 billion IP addresses, but only about 3 billion are actually routable. So when you run your own global scan, consider that 1 IP every 4 is actually not routable. And we notice even more that of the assigned IP addresses, only a few are actually active. And among those, we only pick the ones that are related to companies. That was our goal. We want to measure only companies. We don't care about subscribers, DSL lines. That's a different topic. Okay, so we scanned the internet and we found a lot of vulnerabilities. When you look at the numbers, you see that there are so many vulnerabilities that are well known. They are probably known for 10, 20 years, and they are still there. And we think that this is the reason why companies get hacked. There is not necessarily the need for a very special 0-day to get hacked. Look at how many are these standard vulnerabilities. I mean, you would just need to have a firewall or change your password, and that's what you need to do. So, well, we encountered this large amount of vulnerabilities, and we needed a way to summarize what is how vulnerable you are. And for doing that, we started grouping vulnerabilities into different classes. So depending on what was the problem, we have 4 classes. And we also assigned a severity score. Severity means more risk, more impact. And we start from the straightaway exploits to reaching lower impacts, such as best practice deviations. So for example, exposing ports that you shouldn't expose. Okay, altogether, we have this big map, and we want to have a score. So we attached to each of these severity groups a number that reflects the risk. And we sum those numbers up for each company with a little adjustment, because when you have a vulnerability repeated many times, you're actually not as much as vulnerable as, for example, double. So we have a diminishing factor if you have the same vulnerability twice. And I'll give you an example. So in this case, we imagine to scan a company, and we see that there are only 2 servers available, active, and we found 3 vulnerabilities. But one is a unique one, and one is repeated. In that case, the score of that one that is repeated will not count as double, but will count a bit less. So imagine this in a large scale. I mean, if it's 1,000, we don't count 1,000 more. And then you simply sum up those numbers. This is how we define our hackability score. And then, definitely the difference between a normal Shodan, for example, or census, is that we want to have knowledge about companies, and not only know who is the owner of that IP. That's something you can retrieve from the IP who is database, or a domain who is database, or certificates, for example. That's, of course, the base, but we wanted to add a new set of parameters, metrics, that will allow us to find interesting facts. And, well, we just simply found on the internet open data sets. These data sets allow us to tell how big was the company. So we know that you have such a vulnerability, but we also know that you are a small or big company, how many employees you have, in what industry you work on, where is your headquarters based, and when your company was founded, for example. I mean, there are also other metrics. This is clearly something new. We have more context. We know that just saying you have that many IPs vulnerable is not enough to create the actual answer to that original question. How do I compare to the others? And for this reason, we have now a very big data set. And I think now it's time to get into the analysis of our big data set. And I leave the mic to Fabian.
All right. So I hope that the outset is now clear. We developed the scan engine. We did automated asset discovery. We crawled and found different public data sources, merged them. And now we had a bunch of data, vulnerability data, and we were eager to analyze them and also to just test our own assumptions that we had about security. And let's start the small analysis journey with something very simple and intuitive. The more hosts a company has exposed, the more hackable it is. And of course that makes sense, because if you have more hosts exposed, there is more room for error. The chance that an IP address has a bug is maybe the same, but then if you have more IPs, the chance that you have that vulnerability is higher. But that alone is not too interesting, because I think we need to take those two values and compare them with the revenue of a company. And now this is this chart here. And we can see that with an increased revenue of a company, so this is basically our proxy for the size of the company, we can see that both the hackability and the number of exposed hosts increases. But we can also see that both of those values actually increase a lot less than the revenue. So please note that we have a logarithmic scale on the x-axis. So a step of 1 is a 10-fold increase in revenue, while you can see only a slight increase in hackability. What's also interesting, I think, is that we can see that the number of exposed hosts increases faster than the hackability of that company. So that means that the average hackability per exposed host actually decreases when the company gets bigger. And that also makes sense and is reassuring, because large companies, for once, invest more money into security, and also they should have some like synergetic effects, those big security programs that they are doing. Now let's divide our group into industries and take a look which one are the most secure industries, which one are the least secure. And in the top positions, so of course a lower number means more secure, we can see some maybe more traditional industries like retail that don't need to expose much hosts because they don't provide technology services. But we can also see, for example, banking, which nowadays with fintech and so on is a lot more technologically progressive, but they are still scoring quite well here. And insurance as well. Both are industries that are quite regulated, so that could definitely be a hint towards regulation actually increasing security, but more on that later. On the lower side here, we can see media, software, hardware, technology services. These are all industries that actually need to expose a lot of assets on the internet also, because that's what they are providing, that's what they are for. One note here is that we actually included cloud providers, hosting providers, and ISPs, because we excluded them, and because it's very hard to differentiate between the ISP's clients' IP ranges and the ISP's own IP ranges. And we found that the client's IP ranges have a much higher average hackability, so that would have skewed our results. That's why we excluded them. So as a hacker, if you just want to hack a company, you would now know which industries to focus on. If you are working as a security officer, you may know which companies in which industries to ask for better security best practice tips. But we can zoom in a bit more. This is now across all regions. So let's take a look at one specific industry and compare that across regions. And one of the most interesting ones, I guess, is banking. And first we compare just the regions without going into one specific industry. We can see now the average number of exposed hosts to get to a specific revenue. This is the top chart here. So what this shows us is that North American companies expose more hosts on the internet for a specific revenue than, for example, and especially East Asia. For East Asia, of course, it could also be that they are just more isolated from our scanning view, because there is some firewall in between maybe. But also this could mean that North America is just more technology progressive, while Europe is a bit less. But now let's take a look at the average hackability per exposed host. And here we can see that Europe actually fares quite worse than the other two peer groups. So in overall, this kind of means that while Europe has less hosts exposed, each of the exposed hosts is actually worse in terms of security. And overall, that doesn't seem too good for Europe. And when we now zoom into banking, we can see this difference quite a lot. So banks in Europe are actually, well, more than twice as hackable as banks in North America, on average, of course, and more than 4 times as hackable than banks in East Asia. And remember that we also assigned each of the vulnerabilities we found to different categories. And it gets very interesting here because across all those different regions, we can see a similar pattern. And that pattern is that banks were quite worse when it comes to patches, but are actually really good when it comes to hardening and authentication issues. So patching contributes a lot more to the overall hackability of banks. And it makes sense again, because hardening is a step that's quite easy to do via a checkbox, basically. So you have some hardening steps that you need to do, you check the boxes, and that's kind of what regulation does, right? The same for authentication. You just need to change the password. Do not use a default password. However, patching is like a lot more of an operational process, and some of you may know it, it can get quite messy because it's easy to forget one specific host. It's easy to not know about this one update that I should include. And yeah, that's actually shown in the data as well. So again, as an attacker, you might now know what to look for if you want to hack a bank. If you are a security officer, this might help you to know where you want to focus your efforts on. One assumption that many of us have, I guess, is that it seems like older companies may fare a bit worse when it comes to security. And we graphed that here, again, taking the revenue as a proxy for the company size. And we can see there is probably a slight correlation between being founded before 1980 or being founded after 1990, sorry. Being founded before 1990 or after 1990. So basically, let's say, pre-internet companies seem to have a bit worse security than other companies that were founded after 1990 when it comes to the same revenue. But zooming in a bit more and doing some more analysis, we actually found something interesting. Now, let's not compare it with the revenue of a company, but with the number of exposed hosts. And here we can see a much clearer picture. So a pre-internet company that has 300 hosts exposed has, for example, a hackability score of, let's say, 12, while a post-internet post-internet company has a hackability score of 12, while a pre-internet company, let's say, have a score of 20. So overall, there is around like a 40% difference in the hackability of an exposed host. And now, taking those two insights together, we can see that post-internet companies have more hosts exposed, but those hosts are actually much more secure. So the effect of that is that pre-internet companies are slightly less secure overall, but that is because they have they have less hosts exposed on average, but those hosts that they have exposed, they are much more insecure. Bug bounties also are an interesting topic for us. Everyone assumes that they kind of work, and we cannot definitely say, but what we can say is that companies that have the same kind of exposure and have a bug bounty are more secure than companies that don't have a bug bounty. Now, we cannot tell if bug bounties actually make you more secure, or it's just that more secure companies are going towards bug bounties more easily and makes sense. But yeah, there is definitely a correlation. One minor point here is, if you just compare companies with bug bounties and without bug bounties and take the average hackability, you would actually see that companies that don't have a bug bounty are more hackable. The reason for that is that larger companies tend to have a bug bounty, and that again skews the results. But for equally exposed companies, companies that have a bug bounty are more secure. And we also want to have to know if companies that have been hacked in the past are still more insecure. And also that's the case. And what we used for knowing if a company has been hacked in the past is are different IP block lists. So basically IP lists that contain hosts that have been used, that were part of a botnet and have been used to send out spam. And if that host was part of a botnet, of course that host was hacked. We again got many of those lists, assigned severities, normalized that, and now we can compare that with the average hackability. And the worse the IP reputation of a company is, because it has been hacked in the past, also the higher the hackability that we calculated is. So we don't know if that means that the companies couldn't yet really catch up yet completely. Maybe they also saw that having been hacked was actually not so bad and they didn't care that much. So to summarize those findings, we can say that on average, a software company that is in Europe, has a high revenue, was founded before the internet was big, has a bad IP reputation and no bug bounty, is much more hackable than, for example, a bank in East Asia that was founded recently, has a good reputation and a bug bounty. Now, of course, this is all statistically speaking, so your company might even fall into the left category, but might be a lot more hackable. And also, of course, there is some variance in the data, so don't take it like as our very last words. With increasing the coverage and so on, this might slightly change a bit. But again, you want to compare your company to your peers. And that's why we want to give you the opportunity to know your company's hackability score and also compare it to, for example, other companies of the same revenue or in the same industry. And also we want to give you the opportunity to find other findings, because this is just a small excerpt of what we have found and what is possible with that data. So yeah, we will also give you the opportunity to discover and explore that data by yourself.
Yeah, so we think we did enough, but this data should be shared. So our goal now is to make you look into this data, explore our data, and maybe find other findings. And as Fabian said, the relevant thing is that you can compare the industries. So there is a website, our website. From the main page, you can jump here. There's a link. You can jump to this Hackability Explorer. And I will try to explain briefly what you can do. So you have a chart that already shows the comparison of different regions. On the left side, you see several controls. On this side, you can check and uncheck regions. So also you can do it from the list. And then you can immediately see the result in the chart. Looking back at the data we shared in the previous slides, you can see that globally, the three regions we analyzed, so North America, Europe, and Asia, have a very comparable hackability score. So overall, all the industries together. But as you see, different industries are really different. So in banking, we saw this prominent bar of Europe. So Europe seems to be more hackable. But if you look at software, for example, that's not the case. Europe is much better than US and Asia. And so this is very interesting. You can check your own industry. On the side, I wanted to tell that you probably don't see it well. Oh no, you can see it. The shade of the colors in the chart are representing the quality of the data that we have. So at the moment, if you see the stronger colors, they indicate a very reliable number, while the ones that are a bit more transparent, they indicate that we are having a few samples. So just for you to know. And still exploring, but on a different size. So not regions, but for example, each industries. We have a completely different chart, because what we want to see here is how the score changes with a numerical continuous parameter, for example, revenue. So to clear up a bit the chart, I will unselect some of these lines. And you can see that there is one line there at the bottom, that's banking. Okay. What you can read from this chart is that banking is usually much better than all the other industries until it reaches the point that a bank is so big that probably at that point they cannot control anymore their assets, so their hackability starts to grow. And not only revenue, we said we acquired different matrices, and here you can change it. So you can look at the number of hosts, you can look at profit, for example. And we try to add more of those in the next weeks. We still like to play with this data and share with you. And we hope you have fun and find your own findings. But still, we want to empower those single companies to know, how am I compared to my industry, for example? For doing that, of course, we would need to share detailed information that is not easy to share. So I cannot tell today this company is vulnerable to this specific vulnerability, otherwise the company would be hacked. For that reason, we thought that we would require each company to contact us, or better, to go to a website that we created. And you can reach it directly from the page that you were visiting before. You have to sign up with an email address, and from the domain of your email address, we will give you the results that are related to your own domain. In this case, we had a sample scan that was done for the city of Vienna. In this dashboard, you can click on the scan and see the details. The first thing we see is a summary. In the summary, you can already see how good or bad you are. So to the left, there is a lot of green, so it's a good thing. But then in the middle, you can see that you have these comparison charts. So you are this double circle, and these are other industries. So for example, banks or software houses. And so you can see how you score compared to them in different matrices. So we saw those four, so architecture, maintenance, access management. So you already have an idea how you compare to the others. But as I said, we want to share the full detail to you, because what we care about is that in the end, the internet will be fixed. So if you want to know more about your own vulnerabilities, you can download this free report on this page. The report shows very in detail what are your issues. I don't want to start reading it, but you can see that there are some that are more critical, but there is a long list of vulnerabilities there. And if you are that company, you can start working right away on those. If you want to have more details about what we found, there is a final section here, and there are all the details, all ports and versions and so on. The data is clearly anonymized, but in the real report, it will be the real data. Okay, so this is in our effort as researchers to do something good. We want to empower companies and let them look at their vulnerabilities and fix them. And this was a pretty long journey. We started with, we are security researchers. We also look for very specific, interesting vulnerabilities, but we thought that that's not the way to fix the majority of the insecurities on the internet. We wanted to do something that has an impact, and here is the result. First of all, we share the data with you. You can freely navigate our data, and you can also tell whoever has a company to download their free report. And thank you.
Thank you very much. That was very, very interesting. We have plenty of time for questions, so please go ahead. Just give me a sign.
So 2 questions. One, I assume you looked for like where you introduced error, like either your data sources or something. Like where are you most concerned about the quality of data, where you think there's some bias? And I know you don't want to name companies, but what were some of the really surprising outliers you saw just in general?
As you saw, we had to focus on a limited number of companies. That was around 4,000. Because that was the only set of companies that we could find the information for that was in a good quality. So we only present data for companies that we could analyze the data with high quality. And yeah.
And to answer the second question about interesting outliers, I think what was interesting is that we found security companies actually scoring quite high, having a high hackability. Then we wondered, of course, those could be honeypots, but again, like having honeypots in IP ranges that are easily automated, discoverable and associatable with your security company is also maybe not the best place to put the honeypots. So yeah, that was interesting.
One question. Do you have any idea how hackability correlates with the actual risk to the company? Like, for example, if I have an exposed low-risk asset, for example, I don't know, an advertisement server or something like that, I don't really need to secure that.
Absolutely, absolutely. Absolutely our opinion, us seeing reports from commercial providers that focus a lot on SSL configuration issues and assigning high severity was one of the motivations to start that. And we hope that with the different severities that we assign to different vulnerabilities, we really focus on having basically our penetration tester and security researcher view to actually know this makes the company hackable. Like, maybe a directory listing where there is a .sql inside a file inside the directory listing for us seems more hackable than maybe the, I don't know, poodle vulnerability of a TLS or so. So that's why how we try to really measure the impact and the hackability of a company. And you can also see that we increased, we multiplied severity 4 issues by 8, severity 3 issues by 4, severity 2 issues by 1. So each really severe vulnerability counts a lot more to the hackability than small best practice deviations that as a hacker also give you maybe a tiny bit of information but don't get you too far with hacking that company. So we hope that with basically taking our view as security researchers onto the assigning of severities that we actually could show actual hackability of a company.
Hi, I've seen a tool that is very similar to yours. It's called Open Source Intelligence by Alpha Strike Labs. Do you know how this compares to yours exactly?
I actually don't know the tool, so we will take a look.
Okay, fine. Thanks.
Any further questions? There's still time.
Thanks for the talk and the project. Can you give some words how this project was or is financed? And maybe from whom?
Well, we are employees of a company, so there was no... I mean, it's research. We do research. It's our company.
So, I mean, maybe to tell, so there was no outer finance or so. It's just that our company also does consulting, and we use that money to do the research that we are interested in.
Okay, then one question from me. Would it be possible to extend that research without the monetary aspect to like NGOs to see how they fare with their IT setup, because they're usually quite exposed given or taken there?
Absolutely. So we see that just as a start of a longer journey. NGOs are an interesting topic. I had cities in mind and comparing different regions. So yeah, there's a lot more to explore in the future.
So we can hope for next year that you may send us something for CFP for further results. Okay, if there are no more questions, then thank you very much.